Okay, so we are now going to talk about the different formulas involving circle, segments, sectors, and other formulas which are related to circles. Okay, so first let's talk about the perimeters. So the circle has its perimeter. I mean, the circumference of the circle is the perimeter of the circle. So it can be obtained by the formula C is equals to 2 pi r, where C is the circumference of the circle, r is the radius of the circle, and pi, we consider pi to be 3.1416. So we also have the arc. Okay, so the arc length, if it's not the whole circumference, we have the arc length of of a sector. Okay, wherein S represents the arc length. The theta here is is the central angle measured in radians, and these two lines here are the radius of the circle. So the length of the arc is equal to the radius times the central angle. Okay. So next we have how to get the perimeter of the sector. Okay, so the perimeter of a sector P, so we represent it as P, is equal to the sum of the lengths of the subtended arc. This is the length of the subtended arc and the two radii. Ito. So ito yung perimeter ng sector. So we can write an equation wherein we write P as the perimeter, and then S is the arc length, and 2R is the radii. So, but S is equals to R times theta, no? Dito. S is equals to R times theta. That's the length of the arc. And so we can, instead of writing S, we write R theta plus 2R. So let's factor out R. We can say that P is equals to R, open and close parenthesis, 2 plus theta. Okay, now next we have the perimeter of a segment. So here you can see this is the segment. Okay, here's the segment. Pero itong buong ito yung sector. Okay, now the perimeter of a segment is the sum of the arc length. So ito yung arc length and the length of the chord. Ito. So, ito lang naman yung segment natin dito eh. So, P is equals to S times the L. Now, the length of the chord L may be obtained by the cosine law. When the radius R and the central angle are given, the equation derived for L is equals to R square root of 2 times 1 minus cosine theta. Okay, so to get, that is the, this is the how to get the chord, no? Okay. Now, what about areas of circle? Now, in areas of a circle, the area of a circle is determined by its radius. Thus, if the length of the radius is given, one can always obtain the area of the circle, the semicircle, and the quarter circle by the following formulas. So, area of a circle is equals to pi r squared. And if the diameter is given, we can write A is equals to pi, open and close parenthesis, D over 2, and then raised to 2 or squared. Or we can say that A is equals to pi over 4 d squared. Because if you distribute the exponent to d and 4, this will give you the result. Now, let's take the area of a semicircle. This is the area of a semicircle, one half of the circle, wherein we can just multiply a factor of zero point 0.5 or one half to the area of a circle. So there you can say that area of a semicircle is equals to one half of pi r squared. What about a quarter of a circle? So a quarter of a circle, you divide the area of the circle into 4. So one part is, that's a quarter. So here you can just simply multiply uh, a factor of 1 over 4 or 0.25 or 25% of the area of a circle. Okay. So next, let's move to the next formula. So we have the area of a sector. So area of a sector, we know that area of a sector has two radii and the arc, no? Two radii and the arc. And of course, there is also the central angle. So with respect to the r and central angle, we have area of a sector is equals to 1 half r squared theta. I guess I always already explained this to you in our first part of our lesson, no, in module 1. In-explain ko na ito. So you can just review that part. So A is equals to 1 half r squared theta. Or if r is given and the arc is given, you can use this formula wherein A is equals to 1 half times r times s. Okay. And then we have um, how to get the area of a segment. Okay, so this is a segment, not a sector. So let me correct this. Okay, so this is area of a segment. The area of a segment is equal to the area of the sector formed by the arc and the central angle subtended on the same arc minus the area of the triangle formed by the two radii. So, meron tayong picture niyan. Okay, so if this is your if this is your sector, so let's take this as an example. Okay, so let's say this is your segment class. So you're trying to get this segment. Okay. All right. Now, the whole segment actually can be solved by just taking the area of the whole segment, no? So kunin mo yung area ng whole sector, not the segment. So para makuha mo tong shaded part, no, we're going to shade this, highlight this shaded part. So para makuha mo itong shaded part, which is the segment, no? Segment ng circle. Na para makuha mo to, kailangan mong i-compute ang area ng sector mo, no? Itong buong sector. So ano ba yung sector natin? Baka nakakalimutan natin or we might get confused with sector and segment. So when you say sector, ang kanyang line is bounded by the arc and the radii. So when you say segment, it's the area is bounded by the chord and the arc, no? So therefore, mathematics lang, we can just say that the whole area of the sector minus this area of a triangle will give you the area of the segment. Okay, next, area of a cyclic quadrilateral. Now, cyclic quadrilateral is where the endpoints or the vertices of your quadrilateral position itself on the points along the circumference at the point on the circumference of the circle. So ibig sabihin ang inyong mga points ng polygon na to ay naka-intersect dito sa circumference. So that will be your cyclic quadrilateral. Now, in the previous chapter, you have learned that the area of any quadrilateral may be obtained by this formula, where area is equals to the square root of s minus 1 times s minus b minus times s minus c times s minus d minus a, b, c, d cosine squared of 1 half of the sum of the opposite angles. Now, in this drawing, you can see the opposite angles are A and C. So 1 half of this and then cosine squared. Now, since the sum of the opposite angles of a cyclic quadrilateral is equals to A plus C is equals to 180 degrees, no? Meron din tayong theorem niyan sa polygon, no? You can review, go back to your theorem on that on polygons. So itong opposite angle nila ay equals to 180 degrees. Okay, now therefore, no? If you are going to write this down, okay? So cosine 1 half A plus C is equals to cosine 90 degrees. Tama? Okay, so if you're going to make it 1 half, kasi 180 siya, di kalahati, o 90 degrees. So, it means cosine 1 half of AC is equals to cosine 90 degrees. And cosine 90 degrees is equals to 0. Thus, the area reduces to A is equals to the square root of S minus 1 times S minus B times S minus C times S minus D. So, magiging 0 na to, no? Ito. Ito magiging, itong whole area na to, magiging 0 na to. I mean, not area, this whole term, this will become 0. Now, this formula of finding the area of a cyclic quadrilateral is known as Brahmagupta's formula. Okay. This is Brahmagupta's formula. Okay, so all right. So on my next video, we are going to solve problem exercises based on what we have discussed. So see you on the next video.